Welcome to Calc 19. Today we're going to be talking about optimization. So first, optimization is we find the minimums and maximum values of functions, and we interpret those solutions in the context of their own problems. So these problems are going to be asking to find the minimum profit, the maximum profit, those kinds of things. And so we are not only finding minimums and maximums, but we have to put them in the context of the problem. And we're going to kind of see how that works. So first, we need to actually understand the problem, understand what it's asking for, and identify the information that we need to solve the problem, but also the information we have. Then we need to develop a mathematical model, so drawing pictures, labeling, using variables to represent other quantities. So if x plus y equals 5, we can say that x equals 5 minus y, stuff like that. So we need to first get like our formula, our model, and then we can also graph the function. So a lot of these are going to have domain restrictions, a lot of these functions, because in the context of a problem, I can't have a negative side. I can't have a side that is 0. So we need to figure out what the domain is and what values would actually make sense. We're going to be using critical points and endpoints. So this goes kind of back to our graph analysis. When we look at minimums and maximums, we look at the critical points and the endpoints as well. And then we're going to solve our mathematical model. And if we can find another method, we should use that as well. And then again, we need to interpret that solution into the context of the problem and decide if our solution makes sense or not. So our first example gives us an open top box, and it is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin. And then I'm going to bend up the sides. And it's asking how large should the squares be to make the box hold as much as possible, and then it wants the resulting maximum volume. So my first step is to kind of going to be, I'm a very visual learner, so I want to draw a picture first. So I have this box, and it's 20, that's probably the 25 length. So this length is 25, I have 20 over here. And basically I'm cutting out these squares in my box to fold it up. So I kind of think of this almost as 3D. So I cut these squares and then I fold this side, and I fold this side up and over, and it kind of folds at that line. So the same thing is happening over here. I'm folding it at those points, and I want to find the values of x that are going to make this volume the maximum. So when I think about volume of a rectangular prism, I think length times width times height. And so I know that my height is x, and then I'm going to consider this side my width. My width is actually 20 minus 2x, because my whole length is 20, and then I'm taking off an x here and an x here. So my width is 20 minus 2x, and then my length, same idea, the whole length is 25, so that little part that I'm worried about is 25 minus 2x. And when I'm thinking about possible restraints, here I can already see one. So if I'm looking at 20 minus 2x, I can't go over x equals to 10. So my restraints are going to be, I can have 0. Well, I can't really have 0, but that's kind of like my lower option. And then, sorry, this should not be inclusive. And then my upper option is, there we go, 10. So my lower range is 0, my upper range is 10, because if I plug in 10 for x right here, I get 20 minus 20, and that's 0, so that's not possible. So this is my range. So when I look for critical points, I'm going to be looking at those options, and I'm going to include these as my endpoints. So now I'm going to plug these into my volume equation. So volume is length times width times height. So my volume is x times 20 minus 2x times 25 minus 2x. So now I'm looking for those critical points. I am going to derive the volume with respect to x. And so let's actually, before we do that, I've already done this in my work, but this actually simplifies to 4x cubed minus 90x squared plus 500x. So I did this in my own work just to make it a little bit easier. So now when I'm solving for dB dx, I get 12x squared minus 180x plus 500. Now I'm looking for those critical points, and so I'm looking for where this is equal to 0. And if we can either use the quadratic formula or plug into Calc. So either of those options will work, but our two critical points that we get, the solutions to this equation we get are about 3.681 and 11.317. So those are about our solutions. Those are critical points. But again, can't have anything over 10, so 11 doesn't count. So now I'm going to look at where my volume is 3.681 when x is 3.681, and I also have to check those endpoints. And so when I plug in 3.681, I should get 820.528. When I plug in 0, I get 0. And when I plug in 10, I get 0. So this is the obvious solution. So my question is asking how large should the squares be? And so I can say squares should be 3.681 by 3.681, and there's a few ways you can answer this. And volume equals 820.528. And if we take a look at our units, we are dealing with inches, so cubic inches, so inches. And again, there's a few ways you can answer that. You can say the length of the square should be 3.681, but the volume is 820.528 inches cubed. So this is a similar problem. I'm not going to talk through the solution, but I'm actually going to put the solution on the next page. So I'm going to give you about like 5 seconds to quickly copy this down. And then if you just keep playing the video, the solution will play on the next slide. So you can either try it, or you can just look at my solution and try to get the answer, or you can just not do it. But yes, be prepared for the answer. So here's the solution to this problem. Feel free to pause at any moment to copy down whatever you need to copy down. And make sure to check your answer at the bottom if you did try this problem on your own. So the next type of problem we're going to be dealing with is maximum and minimum profit and cost. And so the maximum profit occurs when our marginal revenue equals our marginal cost. And our minimizing average cost occurs when the average cost is equal to the marginal cost. So these are kind of some new terms. So we use Rx to represent our revenue. So that's what the company makes when they sell a product. And so the derivative of that is the marginal revenue. And then the C of X is the cost, so that's how much it costs to actually make the item. And the derivative of that is our marginal cost. And then we say profit is equal to our revenue minus our cost. So the amount that we make, like how much money we made creating a product minus how much it actually costs to make that product, that's our profit, and the derivative of that is marginal profit. So we're going to be using these in the next problem to kind of find maximum profit and minimize our average cost. So same idea as optimization. It gives us our revenue is 9x and our cost is x cubed minus 6x squared plus 15x. And it tells us that x represents thousands of units. And it's asking, is there a production level? Sorry, that should not say, is there our production level? Is there a production level that maximizes profit? And if so, what is it? So remember that when we're trying to maximize the profit, it occurs when my marginal revenue equals my marginal cost. So basically where my derivative of my revenue is equal to my derivative of my cost. So the derivative of my cost is 3x squared minus 12x plus 15. And I want that to be equal to 9, which is the derivative of my revenue. And so I'm just going to move that 9 over to get this equal to 0 so that I can solve it. So this is plus 6 equals 0. And then I don't have anything that multiplies to 18, but adds to 12. So I'm actually just going to go ahead and solve this in my calculator. And I should get two solutions. I should get x equals 0.586 and 3.414. So these are my critical values. These are the ones I am focused on. And so I'm going to check them in my original cost and revenue because I'm not sure where my maximum profit will occur. And so if I plug in 3.414 into my cost, I get that that is equal to 27.7112. And if I plug it into my revenue, 3.414, that's 30.726. And so my profit, remember, if we look back, profit at 3.414, my profit is equal to my revenue minus my cost. And so I'm going to take 30.726 minus 27.7112, and that is equal to 3.0118. So then I'm going to check my other critical point. So again, I'm going to check 0.586, the cost, and then my profit to see where I am maximizing my profit. So I get that my cost is 6.9308 and my revenue is 5.274. And so my profit again is my cost, or sorry, my revenue minus my cost. And so we actually end up with a negative number, negative 1.6568. And so what this really tells me is that the level for the maximum profit is at 3.414. So this is max profit. And then this is this other value, 0.586. This is where I'm minimizing my loss. So the main one we're concerned with is at 3.414. Sorry, this is not minimizing the loss. This is maximizing the loss. I misspoke on that one. So that's maximum profit. That's maximum loss. And so what we are concerned with is the maximum profit. So now this is going to kind of, again, be a do-it-yourself problem. So I'm going to post the answer on the next slide. So I'll give you a couple seconds to copy this problem down. And I'm realizing that this is the same problem as the last one. So we're given the cost, and we're asked, is there a production level that minimizes average cost? So I'm going to give you a few seconds to copy it down, and then click again, click on pause, which I guess is play, to get the answer. So this is the answer to the question on the slide before. And so this has a little bit more kind of thought to it when it comes to average cost and marginal cost. But basically, it's the same idea. We're looking for those critical points. and then we're kind of solving from there and interpreting those solutions. So optimization is very hard. It's not easy. So that's why we're spending 2 days on it. So just come to class with questions that you may have, and we're going to spend a while working on these problems and the different types of problems that there are. So thank you for watching Calc Chats. Be sure to like and subscribe, and come to class with any questions that you may have.